We have another example on the board. I would start solving this problem from finding the angle. Because I have given power factor, okay, I'm going to use the formula for power factor. Power factor is equal cosine theta. If I want to find theta, I'm supposed to simply write theta is equal inverse cosine of power factor. So I have theta is equal inverse cosine and power factor is equal 0.643 lead. Lead means that your angle is going to have negative sign at front of it. So I have angle equals negative 50 degrees. Okay? Lead means that the current in the load is going to lead the voltage source. This is going to happen when you are going to connect RC circuit to the AC voltage source. Okay, so anytime you have RC circuit, your angle is going to be always negative. In other words, if you are going to have word lead next to the value of the power factor, this automatically means that you're supposed to put the negative sign at the front of the value of angle. Next, we're supposed to realize that we have given Z. So Z is equal 2 kiloohms and angle negative 50 degrees. This is the complete value of my Z total. This is Z total. If you are going to use the calculator right now and convert the polar form of this complex number to rectangular form, you're supposed to obtain 1.28 kiloohms minus J 1.53 kiloohms, where the real part is my resistance and imaginary part is my X of C. Okay, so this is my resistor and this is the capacitive reactance of my capacitor, X of C. Next, we're supposed to find the current. Current in this circuit, I mean I total, is going to be equal to the current which goes through the resistor and to the current which goes through the capacitor, because this is series circuit. How we can find current in this problem? Please notice that we have given true power. The formula for power says power is equal IR square times resistance. We have resistance already. We have given true power, so we can find the current. You're supposed to simply divide both sides of this formula by resistance. Resistor and resistor will cancel out, and we will obtain IR equals square root of P over R. Plug in the values and you're supposed to get square root of P 40 watts over R, which is equal 1.28 kiloohms is equal 176.77 milliamps. Okay, this is the current which will go through the circuit. You're supposed to realize that IR is equal to IC and also is equal to I total. But please notice that we are missing angle. We have to find what angle we are going to have. You're supposed to realize that current total is equal voltage source over Z total. Voltage source is not given, so at this moment we are going to just deal with the angle. If voltage source is not given, I'm going to assume that this not given voltage source is going to have always angle 0 degrees. So what I'm going to do, I'm going to simply write voltage source, angle of 0 degrees, over Z total, and I have angle of negative 50 degrees. Okay, right now I'm not dealing with the numbers in terms of the magnitudes, I'm dealing just with the angles. So I'm going to have the value of my current, which I found, is equal 176.77 milliamps, and angle 0 minus negative 50 degrees is going to give me 50 degrees. As I said, I don't know voltage source yet, but I know Z total and angle. And I found the magnitude of my current. So from this part of my calculation, I'm going to find just angle, which is missing over here. The magnitude I took from here. Okay, and this is my I total. I total, which is equal to IR and is equal to IC. We found I total, so very easy we can find voltage across the capacitor and voltage across the resistor. To find voltage across the capacitor and resistor, I'm going to use Ohm's law. Voltage across the resistor is equal current which goes through the resistor times the resistance, where IR is equal to I total, which is equal 176.77 milliamps, and angle of 50 degrees, times the resistance, which is equal 1.28 kiloohms. This is equal 226.26 volts and angle of 50 degrees. This is voltage across the resistor. If you want to find voltage across the capacitor, you're supposed to use the formula IC times X of C. Okay, so I have 176.77 milliamps and angle of 50 degrees times X of C, and we found X of C is equal 1.53 kiloohms, and angle of negative 90 degrees equals 270.45 volts and angle of negative 40 degrees. This is the voltage drop across the capacitor. Next, we can find voltage source. Please notice that in order to find voltage source, I'm supposed to add the voltage drop across the resistor and voltage drop across the capacitor. So I have voltage source is equal voltage across the resistor plus voltage across the capacitor, where voltage across the resistor is equal 226.26 volts and angle of 50 degrees plus 270.45 volts an angle of negative 40 degrees. You're supposed to use the calculator, and your voltage source has to be equal 352.61 volts, an angle of negative 0.083 degrees, which is equal to 352.61 volts, an angle of 0 degrees. This is my voltage source. Next, we're supposed to find the capacitance of the capacitor. I'm going to use the formula for the capacitive reactance, but please notice that this time we have given omega. Okay, so I have angular velocity given, that's why I'm going to use this form of the formula for capacitive reactance. X of C is equal 1 over omega C. Anytime you're calculating the capacitance, you don't supposed to include the angle. So use algebra and simply write that C is equal 1 divided by omega X of C. This is equal 1 divided by, open parenthesis, 4,000 radians per second times X of C, which is equal 1.53 coulombs. Okay, use the calculator. You're supposed to get the value of 163.4 nanofarads. This is the capacitance of that capacitor. Next, we're supposed to find the reactive power. QC is equal IC squared times X of C, where IC is equal 176.77 milliamps. We don't include the angle at this moment, so I have square times X of C, which is equal 1.53 coulombs, 47.8 VAR, volt ampere reactance. And this is my reactive power. Next, we're supposed to find the apparent power, S. S is equal I total square times Z total. So my I total is equal 176.77 milliamps raised to the second power times Z total, which is equal to coulombs. And this is equal 62.49 volt amp. This is my apparent power. If you want to draw the power triangle, you're supposed to draw the true power. P is equal 40 watts, and reactive power QC equals 47.8 VAR, and apparent power S equals 62.49 VA, and this is the angle theta. So I can say that we solve the problem.